Hello, welcome back everyone. Today this is ELT140 and I'm introducing to you guys today module 3, which is number systems. So here is the module. You're gonna have this video right here at the top, then the PowerPoint presentation for your references. Then after that, I would like you guys to watch these 1, 2, 3, 4 short videos, YouTube videos, and then we're gonna work on the number system practice. So you're gonna have the opportunity to practice 10 times conversion of different numbers. Then we have the control system right here. An ultrasonic welder will be enabled by 2 thumb switches. So these 2 switches have to turn on at the same time. They must be on at the same time in order for your output to turn on. Both must be active at the same time. This is required to ensure both of the operator's hands are away from the welding point. Okay? An alarm input will prevent operation if it's ever active. So you're going to have 3 inputs. 2 of them are going to enable this output. The third one, if the third one ever is on, then it should not allow, it should disable that output, which is the enable for the welding point. Okay. Make sure that you take care of this discussion, number systems, control projects. Just you can make a comment, or if you have any questions, that will be a perfect place to go in there. And then also I'm going to have down here a link for a number system conversion calculator. Okay, so all these that you have here, the number system practice, you can go ahead and you gotta have the answer there. But what I need from you is I want to see the process. All right, and that's why you're gonna have to upload a file, screenshot of the process, how to get to it. But use that link, the converter, to verify your answers. Okay, and through the entire system, as I'm talking, you might want to be using that link, and in order for you to see if you are understanding. Okay, so let's move on with the plan for today. Let's see, PowerPoint. Here it is. Okay. So let's talk about this for a second. We have two systems, right? We have our decimal system. Before we even do that, what is the number system? What is the difference between a numeric system and an encoded system? A numeric system allows us to count. We can count and we can do calculations. So you can count as much as you know, as far as you want to, and you can also calculate things, right? This is in our system is a decimal system. Now, the little bit of a situation here is that we work with computers, and computers, how do you talk to a machine? Well, maybe you can go on and off, right? I mean, the machine will know when to have a voltage or no voltage, all right? So this is where the binary system comes, because now we are dealing with a binary. Is it on or is it off? Well, let's make it into numbers. Is it 0 or is it 1? So that's it. That's the end of it. You have the decimal system. You have the binary system. Now, we also talk about hexadecimal and octal a lot in computers. And the reason for it is these are also numeric systems, but because you can count and you can do calculations. Now, the reason why we use this, you will see a little bit later, is because it's a way for us to wrap our binary system. Very important that you understand this. The only reason why we're talking about octal and hexadecimal is because there is a direct relation with a binary system. I'm also going to be talking about gray code, BCD, and ASCII code. But again, these ones are just a way for you to encode information into zeros and ones. You are not able to count. You are not able to do calculations. So very important that we understand the difference. So I'm not going to cover everything here because I'm already have 5 minutes, and I want to make sure that my videos are up to just 20 minutes, all right? So I already talked a little bit about the decimal system, And of course, the base is base 10 at the decimal system. Okay, I'm going to review this in a second. Okay, less significant bit and most significant bit. Just like when you have in a decimal system, all the number all the way to your right is your less significant digit. While all the way to the left, you have the more to the left you go, the more significant, more higher value. So all the way to the right, to the left, and you will have your most significant bit in case when we're talking about binary. Bits are a digit that is or zeros or ones in a binary system. The same thing that we talk about digits in our decimal systems is anywhere between 0 and 9. Converting binary to decimal, and there's few ways to do this, okay, to convert between decimal and binary, and I'm going to show you the best way that I have, that I can, I'm going to show you the best way, all right, in my opinion. You could do, let's say this number right here, let's get another number, I don't know, let's say, let's say 120. Okay, this is a decimal number. We know what 120 is. Before we move into 120, let's think about what is 120. Let's say 121. 121. Okay, and I want you to look at this part down here. 121. When I say 121, what am I talking about? Well, think about this. The 1 is in the ones value, okay? The value of that column is ones, and then here is tens, and this is 100, and it's 1,000, and we know this. Well, why is that? Well, our base is 10, so you will see here there's 10 to the 0 power, that is a 1. 10 to the first power is a 10. 10 to the second power is 100. I want you guys to remember this. So in any numeric system, you're going to say, okay, what is the number? Is a numeric system I'm going to be using 3, 4, 5, is a 2, whatever it is. And then it's going to be just the same as this. You're going to go, if it's like this one, 10 binary, that's 10 to the 2 to the 0 power, 2 to the first power, 2 to the second power, and it keep going all the way to infinite, right? So when you talk about a 1 here, you means 1 times 1, okay? A 2 here will be 2 times 10, which it will give you a 20, and 1 here will give you 1 times 100, which is 100. So you will have 100 plus 20 plus 1. Very important to understand that. Okay, so now we got this, and you understand that any numeric system, it will be the same. Okay, same rules apply. Now let's think about this 121. Okay, with the binary system here, you have 2 to the 0 is 1, and then 2 to the 1 is 2, 2 to the 2 is 4. Lucky for us, with the binary system, all what you need to do to figure out the next numbers here is just to multiply by 2, if you see, right? So 2, 4, 8, 16, 32, 64, 128, and you just keep going that way. Now, there's another way for you to figure out, it's just dividing by 2 forever. But I'm going to prefer this, I'm going to suggest a different way. Let's imagine that these 121s are 121 marbles, okay? And here, each one of these columns is a bucket that it can hold up to whatever numbers we have here. So this bucket will hold 128, 64, 32, 60, 16, and it keep going like that, right? Okay, so now here is the rule. I have 121, and I'm allowed to use entire buckets at the time. So you see, I cannot go and I have to start all the way from the left. This is what, let me show you what I'm talking about. So let's say 121. Well, this 128, it has too much, right? I need to fill the bucket. So this will not do it. So I'm going to write it 0 here because I'm not going to put any marbles there, okay? because the point is that you have to fill them completely before you move on to the next one, okay? To the next one to the right. So you're going to start to the left. Okay, so now I have 121. Since this is 64, I am going to get a 1 here. So I already used 64. And let me show you why I have these little calculations here, this formula. So I started with 121, and I'm going to subtract 64. So now I have 57. Okay, you can say 121 minus 64. So now I have 57 marbles. Okay, so you see this 32. This is good because 57 is more than 32. Okay, so I'm going to get also a 1 right here. And I'm going to do here 32. 57 minus 32. Now I have 25. Okay, let me keep going here. Okay, so 25. I have a 16 here, so I can get a 1 right here. So that will be, now I have left over 25 minus 16. 25 minus 16. And now I have 9 marbles that are left. So I'm just going to get a 0 here, and a 0, and 0, 2. So we don't complicate things, all right? So now we have 9 right here, okay? So if I get a 1 here, this 1 counts for 8, okay? The same that this 1 counts for 16, this for 32, this for 64. So far, if you add it together, well, let's don't add it yet. So now you have a 9, and you took away 8, so now you only have a 1. And if you look, you cannot use the 4 because then you will have 3 extra spaces. So now you get a 1 right here. So if you count these 1 plus the 8 plus the 16 plus the 32 plus the 64, you will see that this number right here, it will add to 121, and that's how you convert from decimal to binary. Okay. Again, I'm gonna have other videos that shows the process as well. So that's how you convert from decimal to binary. Okay. Now, what about if you want to go from binary to decimal? Same deal. I'm gonna be here binary to decimal. Let's say that I have a number. What did I mean with all this? Okay. Let's say that I want to say 1 is 0 and a 0 and a 1, maybe a 0 and a 1 right here. Okay, so this is your number right here, 101, 1101. This is your less significant bit. Okay, so this one counts for 1. This other 1, look at this, this is that column, counts for 4. This 1 here counts for 8. 0 here, so I don't have 16. 0 here, I don't have 32. And 1 here counts for 64. So now this is your number. 64 plus 8 plus 4 plus 1, that gives you a 77. Again, you have your binary number, a series of 1s and 0s, okay? And then you need to remember that the one to the right, you start from the right, the value of the right one from the top, extreme to the extreme right, and then that will be, the value will be 1, 2, 4, 8, 16, 32, 64, and you keep going like that. And wherever you have a 1, then you are adding that value to your total. Okay, so that's how you convert from binary to decimal. All right. Okay. Now, what about octal and hexadecimal? I have another little chart here that it's gonna help us with this. All right, let's start with the let's look at this table for a second. I should get a different table. So this is your decimal number from 0 to 15. Binary, this is your conversion all the way from 0 to 15. This is all the way 0, 0, all the way to 1, 1, 1. Okay. In octal, these are your numbers. You see 0 all the way to here 1, 7. So let's say this 5 in octal is the same of 0, 1, 0, 1 in binary, which is the same of 0, 5 in decimal. Okay, and this is hexadecimal, right? So let's let's look at this table. Let's look with first start with a hexadecimal, all right? Notice how you go from 0 to 9. Hexadecimal is base 16, and we need, after, from 0 to 9 you have 10, so now you need to come up with other digits, and that's where we have the letters from 0 to 15, which is A, B, C, D, F. Notice how you go from 0 to 15. Look how you have 4 bits, and they go from 000 to 111. That means that you need 4 bits in order for you to have all the possible combinations from 0 to 15. Very important. So now, if you are converting from, okay, if you want to convert from hexadecimal to binary, okay, this is what you want to do. What you're going to do is that you're going to do 1 digit at a time, okay? So let's say that I have, remember, all these are hexadecimal numbers. So let's say that I have a 7A, okay? So this is going to be a 7 right here, 7, and this is your letter A. If you want to convert this 7A, which is in hexadecimal, to binary, all what you need to do is get each one of your digits one at a time, and each one of them will be 4 bits. So you see this A, if we look at here, A is 1010, okay? So I'm going to have here 1010. So that A is 1010, and then let's say your 7 is 0111, okay? 0111, as simple as that. So now you see these series of 8 bits are the equivalent to your 7A hexadecimal is the same as these numbers down here in binary. Okay. What about octal? Notice octal, when you go from 0 to 7, you have 3 bits. Forget about the ones to the left right here, the last 0 to the left. You notice how you go from 000 to 111, 3 bits. Very interesting. So if you use 3 bits, you can represent all the numbers 0 to 7, and then it repeats itself. Okay? So that means that there is a direct relation between 3 bits and each one of the digits in octal. Okay? So let's take a look. Let's say that you want to convert. Let's go from binary to octal. Let's say that I have 1 and a 0 and a 0 and a 1 and a 1 and a 0. Okay, I just choose these numbers right here that you see at the bottom. Okay, this number right here is your binary number. Okay, what you want to do is you want to start from the right, the first 3, 110. Okay, 110. Let's find it here. What is 110? 110 is a 6. Okay, so this is a number 6. And then what about 100? Let's find 100. 100 in binary is my octal in 4. Okay, so 4 it is. So now what we're saying here is that these numbers, these series of bits right here, represent a 46 in octal. Now, do you want to go to decimal? Simply, I already showed you how to go from binary to decimal. Okay, so what we're going to do is, if we are going to convert, let's say, from octal to decimal, from octal you first go to binary, and from binary you move to decimal. Okay, so you're always going to go through binary. If you have a decimal number you want to convert it into hexadecimal, you first convert from decimal to binary, and then from binary to hexadecimal. All right. I'm going to give you some more. I'm going to give you some practice. I'm going to give you some YouTube videos, and I hope this could be a little bit of a challenging concept here. So I understand that. So work with me here. It's going to be okay. All right. So I believe there is a lot of operations that can be done with binary, but in all my years of experience in electronics and robotics, I have never had to add or multiply or divide in binary. So we're going to skip all that, including a hexadecimal. All right. Here is BCD. What is that? All right. So remember, we have the decimal system, we have the binary system, we have the octal and hexadecimal, a way to handle our binary information in a more efficient way, I would say that. Now, what's going on with the binary code? It's also zeros and ones, but it's not a numeric system. It's a way for you to encode numbers. Let me show you what I mean with this, all right? Okay, so I have another, no, is this one? Okay, yes. So a little bit about binary. So let's say that you have a number 93. Okay, this is your number right here, 93. Okay, $93, 93, address 93, which I'm talking about decimal. Okay, now what we do with this is that we're going to get every single one of the digits, and we are going to make it into the, we're going to represent it with a binary number. Again, it's just one digit at a time. All together make no sense, all right? One digit at a time, I'm going to encode the 3, and I'm going to encode the 9, okay? So, you will wonder, well, why do you need 4 bits? Well, look at this. This is my decimal number from 0 to 6 to 7. All the way to 7, you're good on 3 bits. But the moment that you have the 8 and a 9, then you need 4 bits. That is the reason why we need 4 bits. Again, so you have your 3. Well, what is the binary of 3? Is 0, 0, 1, 1. Here you go. That is your 3. And what about 9? Well, look at the 9 here, which is 1001. 1001. And that's it. So again, hopefully you don't get confused about this. BCD is not a numeric system, just a way for you to encode. It could be whatever number. It could be 10,525, and once there's 5 digits there, you're going to get every one of those digits. You're going to represent it with 4 bits, one at a time. Make sure, let's say like this one, these 0 zeros have to stay, right? So just because there's zeros to the left, you cannot say, oh, that doesn't count, so I'm just going to say 1, 0, 0, 1, 1, 1. No, these 2 zeros count. So, okay, and that's it, as simple as that. Yeah, since I just showed you this, let me show you how the number converters work. Let's say that I want to make, and unfortunately there is no BCD here. This is just very much numeric system. But let's say that I have A5, and this is hexadecimal. I'm gonna select hexadecimal, and then so you're gonna be converting from A5 and hexadecimal to, if you wanna make it into binary, this is it. If you wanna go to decimal, it's 165. If it's an octal, so you can select it, and that's how it works. As simple as that. Binary. Let's say that I want a 101, and then this is a decimal 5. Notice how that 101 is the same for octal, for decimal, for hexadecimal. All right, and that's how you use this. What else I need to talk about? We are about to be done with today's presentation. Great code. Remember that we were talking about relays, right? And there was a little problem because the relays, when you are switching them really fast and a lot, they can get hot and they get used and you have to replace them. So the problem is, how can we be more productive? Look at this. Let me show you. Look at this binary system. Let's say that you are counting from 0 to 15 all the time. Here's the little problem. Take a look how, like, going from here, from 7 to 8. Notice how your binary system changed from 0, 1, 1, 1. It goes to 1, 0, 0, 0. So if you have 4 relays, they all switch at once. Okay? So now, with the gray code, you will see how we have another way that we can count where we can only change 1 bit at a time. Look how, if you see all these numbers, they all change only 1 bit at a time. There's not only one standard. You could have, the only rule is that you are able to do all the combinations, which in this case is 4 zeros, from 4 zeros to 15 to 111, right? From 0 to 15, all the combinations will be 16. With 4 bits, you have up to 16 combinations. Well, the point is, can you make these combinations to go only changing 1 bit at a time? Okay, and that's it. That's the only rule, and that's great code. And then finally, the ASCII numbers is a standard way of, of represent in binary all the keys in a keyword. Okay, so and now you don't have the zeros and ones because we have replaced them with this hexadecimal code. So you see that 2A will be 0010, which is a 2, and then the A, I believe, is 1010. Okay, so this, even if you don't see zeros and ones, this is all represented here with your hexadecimal code. All right. And that's it, guys. That's our module 3. And we will continue working on the numeric system for one more module. Have a great day.